My name's Ali Robertson of University College Isle of Man. If you recall from my last video, I actually presented to you the Hadoop ecosystem and the various functions that it undertakes in providing a solution to the big data problem. This is a subset of that really. Now I'm going to be talking to you in a little bit of detail about Hive data warehousing. Many people have heard what a data warehouse is. It's a place where we store pre-calculated information that business managers are known to need on a regular basis. And Hive has its own version of that, born out of Facebook, partly invented by a chap called Sen Sama. It was designed to simplify data analytics within an organization, so you didn't always need to have an expensive developer on hand in Java skills who had to pass out information for managers. So this is something that they could employ a general data engineer to come and get information out in a way that business people actually needed it. So let me demonstrate it to you. Well, it sits and runs with HDFS, which is the Hadoop distributed file system. I have access to it here. This is actually a part of the data lake, a new term that we come across these days when we talk about Hadoop and data store services. What you see here are we have three files we're going to be using here. One's data, one's item, and one's user. And they're all part of the movie lens data set. User are users that have watched some movies. They have watched some movies, we call them items in this data set, and when they watch them, some people actually create a rating for them and say how well they like them, and we have this data stored here too. So I'm going to build a relational data store out of that in a very basic way. It's not complicated, but just to show to you, and your learning outcome is to be able to recognize that Hive is essentially a SQL-based technology, although it's not actually a SQL or RDBMS outcome, which is useful in so many ways. It means you could move into this domain quite easily if you were pretty skilled at doing databases. So how do we get started? I've got my data stored here in HDFS. Now I need to set that up into Hive and create a Hive data store. I've got client access. This is my local Mac machine that I'm working on right now. I'm just going to connect up an SSH over to the main club or hub where the cluster work actually gets done. Let me just keep myself a bit quiet while I type in the password because I can't multitask. That's me now logged into another machine. To actually start Hive, I just type Hive shell. There has to be a hyphen in that too. Oops, maybe it's just Hive. It is just Hive, and that's going to run. You do sometimes find a bit of a lumpy service with this. I have found in the past that sometimes I haven't been able to really well connect on using this Hive command. Sometimes it's good to actually run something else called beeline as well. I have a list of commands here in this file here, which includes beeline. And just to introduce you to the concept of that, I'll do all the work via beeline. To be honest, I'm just going to copy this command over, drop it into my command prompt here, and run it. It's only a little bit of a fudge really to get it through. That's me. I'm connected onto my database now. And that should all just work just fine. Now, in this text file here, I've got a whole bunch of commands I'm going to run. Before I get going on those, I've been building this database previously to demonstrate to other students. So what I'm going to do now is drop all of the tables in it, but that'll give you an insight into how easy it is to move stuff around in Hive. So I'm going to drop three tables. Drop table, and one of them is called uData. Must finish with semicolon, or I'll expect another command on the next line. Just like a SQL command, isn't it? Now I'm going to drop the other one, which is uMovie. Done. Now I'm going to drop the last one, data movie, so this has got to be user at this point, and it's done. I now have a clean slate I can work on. Now I have a bunch of commands on here which I'm going to run through in sequence. Well, first of all, I'm going to run this command. I need to build three tables. One for users, one for items, which are movies, and then one for rating systems. So what I've got here are create table, uData. This is in SQL language essentially. Create a table called uData. 1, 2, 3, 4 fields are going to be opened up. User ID is integer, movie ID is integer, rating is integer, and Unix time is a string. And the file that you're going to be pulling in to make this table off is actually going to be fields that are terminated with a tab, which means it's tab-separated data. And I want you to store this in HDFS as a text file. And that means you can access it in other ways whenever you need. which is handy when you start using things like Spark to get machine learning algorithms working on this data. So if I just copy all of that code over and hit enter, that should just run without error. But no, beneath that I've got another command here called load data. We'll have a look at that when I get it into the screen above. Load data in path, user hive udata. Overwrite into table udata. It speaks the language of SQL, it's really understandable. That's table 1 done. Just to make sure it is there, select star from u underscore, and that was data, wasn't it, that I've been working on. Semicolon. It's now going to pull that data back. That's installed, 100,000 rows of data. It just flashed up in front of the screen. It is a big data system, it works with that fluidly. That's not big, 100,000 these days. One of my files that I work with is actually 28 million rows of that type of data. So, and that's not big either. Now let's build the other 2 tables, and then we'll have a look at the relational aspect between the 3 tables I intend to build. I'm now going to copy it and create the user table. That's entered. I'm going to load the data into that. And enter. Done. Another quick check just to make sure it's taken. Don't normally have to do that. Just as a bit of a background while I do this, by the way, Hive is not high latency. Oh, sorry, it's not a low latency. It's not a fast technology, which means, there it is, my data's there. What I've got here is the user ID, their age, male or female, what they do for a living, and their postcode where that information is available. Yeah, what it means is it's definitely a data warehousing technology, not a fast-moving database technology. You couldn't have like 100,000 or entries coming into this a minute or anything like that. It probably wouldn't be very good for that. It's not what it's designed for. You load your data in, it stays there in that format until you need it, and then you update that later on if you need to by overwriting it more than likely, depending on the scale of the job at least. Whereas next week I'll show you the technology of HBase, which actually takes that a little bit further, has a little bit better than that, and actually is much faster, high-frequency data. But then you can take the HBase data and push it into this space in Hive whenever you need to for the longer-term analytics stuff. So that's 2 tables now loaded. I just need one last one in, which is I'm going to add my movies to the pile. So I'll have my 3 tables to work with relationally, and hit enter. That's gone in, and now upload the data to that, and that should be done. And that should be it done. Now, I'm going to go back to HDFS here. I'm going to go back to the command line prompt in a minute. These 3 files have now been sucked into Hive World. So if I click refresh on this screen, they should all disappear. And they have just disappeared. And what that means is my information is now stored in my warehouse. See where it says warehouse when my mouse is moving there? So I'm going to move into table space, managed, Hive, at the bottom of there, udata, umovie, and uuser. All my data is now safely stored in my Hive warehouse. I can use it as and when I want. So let's do that. Let's go back to the Hive warehouse, and let's just a pre-built command that I'm going to put in here. It's a typical joined relational query, just to release and have a look at all of the data. I'm just going to paste that there. So what I've got here, I've got select IMDb, and IMDb is the IMDb movie rating service, if you will, and so it just pulls back the web address for that. So imagine you've got somebody that comes in and they find a movie and they might want to look at that address. This is what the query that you would part at least design to present that onto a web page. So from underscore user table, join underscore data on user ID, and then join umovie on udata movie ID, and again on movie ID. And these joins are inner joins, not outer joins. They're actually inner joins as by automatic and by row. If I hit enter, I get a bunch of command line stuff pop up. That takes a wee while to do because for my old machine, it's a 2012 Mac Pro. It's got a bit of work to do to get that information out. I can't hear it in the corner, but there it is. It's pulling out all the information that I need. It's basically releasing every row in that data set in a denormalized way, essentially. So that's Hive. It's no more complicated than that. It's a data warehousing tool. I've only shown you a sparse layer of it. Actually, you could, if you had something like the AdventureWorks database, you could have it installed into this space and do all of your data warehousing in this area. You don't have to just use Microsoft tools anymore if that's your preference. Best to be done in big data, genuine big data environments. Now, I look forward to presenting you my next video of choice, which will be on HBase, which will be delivered in about a week or two's time. I hope you're getting on well with the course so far. I'm enjoying databases. It's an exciting place at the moment, databases. I look forward to speaking to you again soon.